Good afternoon, chemistry class, or if I know some of you, it's probably in the middle of the night and you are still up doing some work, which is okay. We're doing some stuff online. I'm going to walk you through question number 11 and 12 in the practice problems. This is going to be our first look at using the mole relationships, the mole ratios, in order to have information about one thing, but be able to talk about something else. That's the magic of this. That's the beauty of, it's not magic, it's math. That's the power of stoichiometry here, is that we can have information about one thing and find out everything else we need to know about every other thing in a balanced equation. Trick is, we have to have a balanced equation. So let me flip my camera around over here. And we will get ourselves started, okay? So the first thing we have to do is balance the equation. And I'm not going to take the time to walk through the long step of that. Let's just see if we can quickly get this done. So we see here our carbons are balanced at 1. We've got 4 hydrogens here and 2 hydrogens here. So I might think I wanted to put 2 here, but I'm noticing that I've got 2 sulfurs here and 1 sulfur here, and then 8 over here. So I want to make sure I can get to an even number somehow. So let's see what it is that we might need to do with this. So let's actually take this up a little bigger than we might originally think. Let's go with a 4 here and fix this. So 4 times 2 is 8. And that means we would need a 2 here. If we put a 2 there, so then 2, so at least our carbons are balanced, our hydrogens are balanced, and let's check on our sulfurs. 2 times 2 is 4, plus 4 more is 8, so we are balanced and ready to go. This is on page 275 in your textbook, so if you want to follow along and get that in your notes. I will say that we'll often start with a balanced equation, but that might be part of the process, is one step is balancing it and then getting started, okay? So that's part A. We have done part A. We have balanced our equation. B. This says for us to calculate moles of CS2, carbon disulfide, produced when 1.5 mole of sulfur is used. Okay, so let's look at what the balanced equation tells us. The balanced equation tells us that when we use 1 mole of sulfur, we produce 2 moles of carbon disulfide. And you might already be thinking that you know what the answer is. And that's fantastic. But what we have to do here is set it up so that our words work out. So sometimes I will even do something like this. I will write what I know. So I know that I have 1.50 moles of this. And I want to know how many moles of this, right? So right now, that's the only mole ratio that I care about. Even though I know that I could write one for everything else here, that's the only one that I care about. And I am always, as we did in our particle mole to mass equations, we're always going to start with the information. We're going to start our math with the data that the problem gave us so we don't get off track. So I'm going to write down that I have 1.50 mole of S8. All right. Now the problem is my answer does not need to have mole of S8 in it. My answer needs to say mole of carbon disulfide. So I have to have a way to change the conversation. So we're going to do a mole ratio here. The mole ratio from the balanced equation is 1 mole of S8 yields 2 moles of CS2, right? 1 mole to 2 moles. So now mole of S8 cancels. So now I can see that my words have worked out. Now, what math am I left with? Well, this is 1.5 times 2. So that is 3, we can say 3.00. These counting numbers are going to be, and this is this 2 mole here, that's an exact number. So I had 3 significant figures here. 3 moles of CS2, carbon disulfide. That problem is now solved. That's all it was asking us, okay? One-step problem. How many moles of this? I know the mole ratio, so I can calculate the moles of a new thing. Let's look at letter C. Letter C says, well, in that case, how many moles of hydrogen sulfide are produced? Now, we weren't given any new information, so now this time I have answered this question, so now I want to know how many moles of hydrogen sulfide. I'm going to start with the same information that I was given to begin with. 1 mole of S8, because that was my given data. Then I'm going to write the mole ratio. So I want this information to go away. So 1 mole of S8, because the balanced equation says it's 1, understood 1. 1 mole of S8 produces, 1 mole produces 4 moles. Please use the word mole there. Don't just write 4. Don't write 4H2S, right? Write the word mole. H2S, all right, equals, mole cancels, and now we are, and just, I know you'll want to, grab your calculator, 4 times 1, whoops, I said 4. 4 times 1.5 equals 4 times 1.5. I knew it wasn't 24 because I had left the 4 in there. 4.00 mole H2S. Okay. So that's the final answer for B and C. All right, using the balanced equation. All right, let me set up the next problem for us. This is the challenge problem there for number 12. But let's take a look at it. It's not too hard. Writing the balanced equation was the hardest part for this question, and I went ahead and wrote it out for us. It says that this is produced, so sulfuric acid is produced when sulfur dioxide reacts with oxygen and water. So now all we need to do is balance this equation, and we'll see here that the hydrogen, H2, it's balanced. Sulfur is balanced, 1 and 1, but got 1, 2, 3, 4, 5 oxygens on this side and only 4 here. So we need more over here. So the logical thing to do would be to put a 2 here and see how that helps us. Now let's balance everything else. 2 times 2 is 4, so we need a 2 here. 2 sulfurs, so we need a 2 here. Now let's count our oxygens. 2 times 2 is 4, 5, 6, 7, 8. 4 times 2 is 8. So now this balanced equation is all ready, and that was letter A. Again, in a lot of these, we will have a balanced equation provided for us, but on these first couple, then it's asking us to balance it and practice that. The question that we have in front of us for letter B is, how many moles of sulfuric acid are produced from 12.5 moles of sulfur dioxide? Now that's interesting because that's not typically something that we might do so easily in our heads. So let's take a look at this, except I'm seeing that it might be easier than we might think at first. So we're going to start, let's do this again. Let's mark what we know. All right, so it says that we have 12.5 moles of sulfur dioxide, and we want to know how many moles of this. So those are the only 2 relationships that we care about here. So 12.5 mole, and if you see the answer already, you're going to not want to do all this work, but we have to do the work to support it when it's not easy, right? So the balanced equation ratio is 2 moles of SO2 over 2 moles of H2SO4. So we see it's 2 moles to 2 moles, right? So we get rid of the words. If it's 2 to 2, then we would divide by 2 and multiply by 2. So that means the answer is just 12.5 moles of H2SO4, correct? Right? It's a 1-to-1 relationship. And that's going to be how much is produced. Let's look at C. How many moles of oxygen are needed? Oh, wait, you mean that I can give myself information about a reactant? Absolutely, because when we wrote all of our mole ratios, we were able to write a mole ratio for everything in the balanced equation, correct? So now we want to know how many moles of oxygen. So let's prep this one real quick. Again, we're going to start with the data that we have, 12.5 moles of SO2. Reacts with, let's say 2 to 1, right? 2 to 1. 1 mole of SO2, 1 mole of O2. Not leaving out any of those words. This is multiplication is indicated, multiplication and division. So we're going to take half of that, right? So 12.5 divided by 2, 6.25 mole, cancel our words out, of O2. So now that is the correct answer for C. There is our correct answer for B. And that is how we solve a one-step where it's mole to mole, right? Mole to mole. I'll post some questions for you to work through those, and then you'll have another video that takes us in a different direction.